Hey everyone, this is Mr. Wyrick, and I'm back with you here. We did have some people qualify for the regional competition, so it looks like I'm going to miss a couple more days for tennis. Sorry, everybody. I really want to be back in there. I want to be going over this stuff with you because I do really like probability and statistics, but this is going to be for the notes over sets and Venn diagrams. If you want to just kind of follow along there, and I'll talk about what's on each slide. So slide number one, just the title. Slide number two, what are sets? A set is a collection of items. Everything that's in that set is known as an element. A lot of vocabulary on this one. We usually have the nice curly braces, the ones that are the tough ones to draw properly, but you'll be typing those. It's the keys just to the right of P, the shifted version of that, so they're really easy to find. So there's some examples of sets on there. D equals Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. So that's like the days of the week is the set. And the elements would be the different days of the week. And then it has on there I for ice cream, and they have chocolate, vanilla, and strawberry. Everybody loves those big three. The next slide is talking about notations. This is a set builder notation, and it has on there the variable and the conditions. So we're saying the set S is equal to X, and then we have the 5 is less than X, which is less than 10. This would be everything that we can fill in for X between 5 and 10. That would mean that instead of being individual numbers like was on the last page, or like the individual days of the week, this would be infinite. Since 5.003 is between 5 and 10, that's an answer. Since 7.326 is between 5 and 10, that's an answer. Since 9.9999999 is between 5 and 10, that is a correct answer. So there's infinite answers within that individual set. Sorry, I'm looking at the screen right behind the camera here. On slide number 4, what do all of these symbols mean? When the one that looks like the E on the vision test, that means it is an element of a given set. The E with the line through it, that means it's not an element of that set. So if we say X is a positive integer, a set of numbers where X is a positive integer, then 7 would work because 7 is a positive integer. So it would be an element of that set S. So that's why I had that 7ES. 7 is an element of S. Negative 2 is not an element of S because negative 2 is not a positive integer. It's not positive. So it does not belong to set S. A lot of stuff to kind of look for here. Notation of specific sets on that very next slide, that's slide number 5. U means it's a universal set. It contains all the elements being considered. The 0 with the line through it, that's an empty set. That means there's a set with no elements. I use that one a lot in Algebra 2 to mean that there's no solution. The solution itself is an empty set, no answers. The tiny c is actually, it's the bottom part of that E. Instead of being an element, it's a subset. A is a subset of B. Every element of A is also an element of B. So this one goes back to like what we were talking about when we started talking about squares. Squares are rectangles, and rectangles are parallelograms. So if we had a set of all of the parallelograms, we would have a subset then that were rectangles, and we could have a subset of those rectangles that would be squares. And then we have the A, which looks like raised to the C, kind of. And it's the complement of set A. So it's everything else that is not in set A. So if we had a set that was supposed to be even numbers between 0 and 10, then we would have these different numbers that are elements of that set, 2, 4, 6, 8. And then we would have a complement set, and the complement set would be those negative numbers. Okay, they are not part of that set. Okay, So there's some different things to unpack here. There's some different things to look at. If we look on number 6, U is going to be all integers. Here's the subsets. A is X has to be an element of U. It's going to be an integer. It's going to be a whole number. And it has to be greater than 3. So that would mean, 4, 5, 6 would all be good. B, X is an element of U, so it's going to be an integer. And it's even, so it has to be 2, 4, 6, 8, 10. On letter C, it says X is an element of U, so again, we're talking integer, and 2 times X is an odd integer. I don't know how that's going to work. You can't usually double something and end up with something odd, especially if it's an integer, so that might be an empty set there. And then D, X is an element of U. It's whole numbers, it's integers, and X is odd, so 1, 3, 5, 7, 9. So which one is the complement of B? Well, since B is the evens, the complement of that would be the odds. So the complement of B would be set D. Which set is an empty set? That would be C. You can't multiply whole numbers by 2 and end up with an odd. And then which set contains the subset 1, 3, 5, and 7? That would be D again. 1, 3, 5, and 7 would be correct answers, but they are not all of the correct answers to D, so that is a subset. Did I catch everything on that one? Okay, I caught everything on that one. Number 7, you can also represent sets using Venn diagrams. You're used to Venn diagrams, hopefully. You've seen some of them in math. You've seen some in English. Everything in circle B is circle B alone. Everything in circle A is circle A alone. And everything in the overlap is both of those things. So those are always kind of interesting to look at. Number 8, the union of two sets is everything. So all the adults and all the students that are inside of Centennial. So you could make an argument for, any student who's 18 years old is an adult. So that's where we get that overlap between A and B. But if you want to say everyone inside of Centennial, that would include the adults and the students. So then the intersection of the sets is just the ones that have those things in common. So again, if we want to talk about adults at Centennial, students at Centennial for like A and B, those students that are 18 that it would be considered adults, but they are still students of Centennial, that would be our overlap there on that second image. So on our example, this is the kind of stuff that I hope you're looking forward to on the quiz. I kind of look at them as logic puzzles, but they do fit into math. Which diagram represents the following sets? P, where X is an integer divisible by 2, so that's even numbers. Q, where X is an odd integer, and R, where X is an integer divisible by 3. It's important to note that those even numbers and odd numbers can't touch. So the middle option is out. You can't have P and Q overlapping. No number is both odd and even. And then we've got our answers from either the first one or the last one. Well, there are some numbers that are even that are going to be divisible by 3. There are some numbers that are odd that are going to be divisible by 3. So we need to have overlap with both of those. So it needs to be the one with the overlap between R and P and R and Q both. So the one over on the left side of the screen. Question 10. U, the big square, is everybody who was surveyed. Everybody in the D circle is allergic to dogs. Everybody in the C circle is allergic to cats. Everybody in the P circle is allergic to pollen. So how many people are not allergic? That's that hidden 22 down in that bottom left corner. How many people are allergic to all 3? That's the overlap of everything. That one poor sap who's allergic to everything. That's kind of me. How many people are allergic to both dogs and cats, but not allergic to pollen? That's the overlap between the D and the C, but we don't want to include that one person who's allergic to everything. So 7 people. And then how many people are allergic to cats only? that's the 18 that are up there just in that C circle that are not part of any other circle. And then the last question, how many people are allergic to exactly 2 of these options? That's all the overlaps excluding the one that's overlapped by all 3. So the 7, the 12, and the 10, that would be 22 plus 7 is 29 people that are allergic to exactly 2 things, but not 3. So that should get us through the examples. Hopefully you understand a little bit of what's going on here. Again, you have 3 chances to do this. This one is a quiz in Edgenuity. It's sets and Venn diagrams, so make sure you take that quiz if you get stuck on it. I will be back on Thursday. I can help you out. I will do my best to let you know that I appreciate being back at school with students doing the other part of the job that I get paid for. So thanks a lot, guys, and we'll see you later.